In this video, I will introduce the definition of a linear transformation before we talk about the most important kind of linear transformation. A transformation, T, from the vector space Rm to Rm is called linear if it has two properties. The first property is that it should distribute over addition. The second property is that we should be able to factor out constants. And this should work for any vectors u and v or scalar c that we might plug in to the transformation. Now let's move on to our example of the most important kind of linear transformation. Suppose that our transformation T is a matrix transformation that's given by the matrix A, so that T of U is equal to A times U, where A is our matrix. Let's check the two properties for a linear transformation. In order to do this, we'll have to plug in two vectors, the sum of u plus v. Since T is a matrix transformation, what we get is A times u plus v. Now we can use some of the properties of matrix multiplication that we've already learned by distributing the matrix A across addition. And then to finish off the first property, we remember that A times U is really T of U, and A times V is really T of V. Now we move on to the second property of linear transformations. This time we'll plug in a scalar times the vector U. Again, T is a matrix transformation, so this is A times C times U. And then we have to think back to properties of matrix multiplication. In this case, property 5 of matrix multiplication, that tells us that we can move scalars around anywhere we like. So let's move it out to the front. And then to finish the second property, we remember that A times U is really T of U. So we can conclude from this example that all matrix transformations are actually linear transformations. That means that the rotations, dilations, and reflections that we saw in the previous section are all examples of linear transformations. Going back to the definition of linear transformations, you might want to try to think of other mathematical ideas that have these two properties. Two important ideas that come to mind are derivatives and integrals. If you take the derivative of a sum, you can break it into two derivatives. If you take the derivative of a scalar times a function, then you can factor the scalar out. And we can do the same thing for integrals.